Hello and welcome to my bench. Today, you see here a Cobra 142 GTL, but this radio will not be in the focus today, because this radio has been for more than 25 years or maybe 30 years on the attic. So that means the radio was really for a long period of time not in operation, and therefore the owner is now thinking about restoring this radio, or he do not really know, and he asked for a status report to decide what he gonna do with this radio. Well, what you should know, in the 70s, when CB radio became official in Germany, only amplitude modulation was allowed. So this Cobra was already an imported radio, most likely from the United States, and it was not allowed to use this radio in Germany. These things have now changed in Germany, so it is all the different modulation types are allowed in these days, so AM, SSB and FM, but today it is more the problem that most conversations on CB radios happens on frequency modulation. So it is clear that the owner of this radio is really thinking about what he should do, because 30 years old and 30 years not in operation, and then without frequency modulation, does it make any sense to restore it for Germany? So it is slightly different to the United States, where we know that all the Cobras, especially the Cobra 2000s, be restored for a lot of money, and that makes sense because you guys in the United States still use AM, and therefore that is a complete different story. Well, anyway, that is definitely a complete different discussion. So that will not be the focus of the video of today. So today we want to talk about how to take a radio back into service after such a long time without main power connected to the radio. You can see this radio has an internal power supply, so it will be directly connected to mains. And as you do not know what has happened over the last 25 or 30 years at the attic, we do not know how the radio would behave if you directly plug it into the wall plug. You really could destroy the radio, because there are a lot of capacitors inside which could be leaky, and you have the net transformer inside, and well, a lot of components you do not know what has happened to these components on all this time passing by. So, well, you should not put an old electric device directly to the wall plug, because yeah, you can really damage you everything. So what can we do? Well, in this discussion, yeah, this little thing will come into place, and well, what the hell is this? Well, it is nothing else but light bulbs. So yeah, if you ever put an old electric device back into service, you should always put light bulbs in between, because these light bulbs can really help to make this first operation after a long period of time safe. So it will protect your radio, where you really don't know what has happened in the last 20 years to all the different components in this radio or in any electronic device. So you know, these light bulbs are really helpful, and you plug the radio directly to the light bulbs, and then on the other side you have again a plug which you put into your mains, and then you really can switch your radio on and see what the behavior is. But putting light bulbs in between, what does it mean? Well, basically it is very simple. So let's have a look to this schematic. So all these three light bulbs are put in line with our power line, and so you know, it is really in series. It is in series with, in our case, with our radio. And well, the beauty of these light bulbs is they have a PTC behavior. So that means when you know, the filament inside of the light bulb, so you can easily see the filament here inside of the light bulb, and well, when the light bulb is cold, then the resistor is very, very low, and if you switch a light bulb on, then a current is running through the light bulb, and then it starts immediately to develop its resistor. And well, as we already know, this little formula down here, so this is our power formula, and it is also valid with these light bulbs. We can easily take this formula to calculate our resistor, and using you know, this formula, we can easily determine the resistor of, for instance, this 100 watt light bulb, and as well the 60 and the 40 watt. And you see these resistors, 529 for the 100, and the 881 for the 60 watt, and the 1322 for the 40 watt is the resistor. Then the light bulb is hot and producing light, at least, and then these resistors are valid. But as long the filament is cold, the resistor is very, very low, and that is really something what we can use for our purposes to test an old electronic device. Because, you know, if we connect it like it is shown in this little schematic, you know, the current which is flowing through will not directly heat the filament, and that means the resistor stays very low. Even the radio is already switched on. But the advantage is, imagine that there is a short somewhere in the radio. So that would mean we have a short between this both wires internally. So maybe there is a capacitor with which is shorted out or whatever. So it could be anything. And in this case, you know, we have of course a short in the radio, but we have still our light bulb in between, which is then protecting our radio. Because you know, if there is a short, then immediately the light bulb comes up and starts lighting. So you know, oh, there must be a short. And secondly, the internal resistor of the light bulb is finally reducing or controlling the current which is flowing through your short in the radio. And that means it is protecting all the components which are involved in your short. And that is really helpful because you protect the defective component in the radio to blue completely. So you know, this is the best way to take an old electronic device and radio, an old radio, back into service, and you protect the circuitry in the radio. The light bulbs control the current through the radio, and therefore that is really the best idea. And well, why do I have three different light bulbs? Well, very easy. So I can switch the light bulbs with this little switches down here, and I would always start with the 40 watt light bulb, which is this light bulb here. Why? Very easy. It has the highest resistor in operation. So if there is a short in the radio, we have 1322 ohm in between, which will control and limit our short to the current which will be fly through the short controlled by this resistor. So I always start with the lowest with the light bulb with the lowest watt, because of the highest resistor. And then when I see nothing happens, I can immediately switch to higher light bulbs with higher watts, to reduce the resistor and give more current into the radio. But still it is protected with you know, the resistor which is here in between. And if you are nearly certain that the radio is not producing a short, and you have the feeling everything is good, then you can switch on all three, and that makes the resistor even lower, even the resistor when the light bulbs are switched off, because they are in parallel, and that means that even the resistor under cold conditions is then the lowest ever. And still then you have you know, the protection in place. But okay, let's see how it works out when we really connect it. Well, okay, so let's plug my light bulb battery here to, well, I have the advantage that I have still this nice transformer which is adjustable. So I switch on my my transformer, and I can adjust it to nearly not nearly to 0 volt, and then I can easily plug it here to my transformer. And okay, now I have no radio connected to this, because this is another wall plug where I can finally then put my plug into. But now I have switched, I have now connected my light bulbs here to my transformer. And well, for this explanation, let us put it to 230 volt. You can read the voltage down there, but you also can read it here. I don't know if you can read it through the camera. Let me see. We can do it like this, and you see now it is 230 volt, which is the voltage we have here in Germany. And as far as I know, 230 volt is the voltage in most parts of Europe. But anyway, in Germany it is 230. And well, yeah, to demonstrate how it works, we will do now a little test. Okay, so I have now this test wire here, this lap wire, and I have already put one side into the wall plug, as you can see, and I will now switch the 100 watt light bulb on like this, and let us imagine that this wire will be the short in our radio. And what will happening if you know, normally it is clear that this wall plug would be inside, but if there is a short in the radio, it is nothing else than we would directly produce the short down here. Now the 100 watt light bulb is switched on, and now imagine we would produce we really would produce a short in here. Have a look. So this lamp is now on, and that is a clear indication for we have a short, right? So that is nothing special, that then our light bulb is on, right? But you see as well, so there is not a big bang because the light bulb is now controlling the current which is running through the short, and that is really the good thing of this little construction. And as you see, it is simple because it is homebrewed, so you can do it by yourself, and then you have really a good protection for your radios or other electronic devices, maybe old tube radios, which you want to take into operation after a long period of time, maybe 60 or 70 years, whatever. So now let's take our lab wire away from it, and let's switch this off. Now there is no power available here at the wall plug. Let me now place it a little bit more. Let me see how we can arrange that you can really see both. Let me first, well, you have seen all switches are off. The radio is connected to the transformer, and the transformer is adjusted to 230 volt, so everything is fine right now. At the wall plug we do not have any voltage for the moment in time, because the switches are off. And now I can put you know, the wall plug here into the socket. And well, the radio is still switched off, but I do not know where this switch is connected to. So even if this switch is off, there could be already mains at your internal power supply. So don't let yourself confused by switches like this. Or you have already studied the schematic to know how it is connected to the internal circuitry. Okay, and normally I would slowly increase the voltage by adjusting my transformer output, but I don't want to do it right now, because normally you don't have adjustable transformer, so therefore we leave it at 230 volt, because it will work in this configuration as well. Because if there would be an short inside the radio, then immediately the lights would switch on, and yeah, would really protect your radio. Okay, so everything is on. The switch here is out, but now I will switch on here our first lamp, which is the one here, the last one here on the right side hand, and I will switch it on. And what you have seen, that it came up for a short time, so that means there is already something connected to you know, mains. So maybe that the switch is you know, maybe the switch is behind the line power. So that is the reason why we saw for a very short time that this light bulb starts glowing and then goes down again. So let's try if we can reproduce it once again. And yeah, you have seen it. At a very short time it came up, and it was directly controlling the current. Once again, we try it again. Just have a look to this light bulb, and yeah, you may have seen it. So that means, okay, so there is something going on. But it is not a complete short, so this was only during switching it on, or plugging it into the wall plug. And now we will switch it on and watch this lamp, what gonna happen to it. And secondly, this radio has not been switched on. I do not know what is gonna happen to the radio. Will it fire up or not? I don't know. We will see. And anyway, everything what will now gonna happen will be controlled by this light bulb. So let's see. Have a look. So this light bulb is controlling the current through the radio, and because I don't want to have it glowing, I switch on the second lamp here, light bulb here, and now you see this both resistors are in parallel, and therefore now this both light bulbs are not glowing, because that is what we need, because we need the resistor inside the light bulbs to be low, right? And the resistors are only low as long they are not glowing. So that is really important. But they are still in line, and they are still controlling the radio, or not the radio, so more the current which is flowing through the circuitry. And you may not have seen, because the camera was a little bit too much on the left hand side, so you may have missed that the radio is really firing up, so that is working. But let us have once again look onto the schematic. These both switches are on, so that means that these both light bulbs are in parallel, and now the current is flowing through this both light bulbs. And what we can say so far, the radio fired up, so something is working, so we do not know. Listen. So the speaker is working as well. So the audio frequency stage is working, and yeah, let me check. We can change the channels, and so the switch is dirty, so that is clear. And well, but let me turn it down. But the most important thing, so there is obviously no short inside the radio, and you know, you should leave your light bulbs in between for a couple of hours, because sometimes old electronic devices develop a short after a short period of time after switching it on. So it is really a good idea to leave your protection light bulbs in between, and you now can do your first check. So now I will, because I have to give a status report. So what I gonna do right now, I will hook it to the communication tester. I gonna check if the receiver is still working, and I will check if the transmitter is working, and I try to figure out what the current status of this radio is. And well, but I will leave the light bulbs in between. The only thing what I gonna do right now is I gonna switch the 100 watt light bulb also on, just because I want to have all the three light bulbs switched on to reduce the overall resistor under cold conditions, because I try to bring the radio in yeah, you know, the most normal operation condition. So therefore all the three light bulbs are switched on, and yes, there is still the resistor in between, so this will reduce the current which is flying to the transformer internally. But I think that doesn't make or doesn't produce any problems. So now we can do our first tests with the radio, and if within the next hour or so because I will leave it running now for I don't know, for an hour or two or whatever, just to leave it running and see if it will develop a short or whatever, and therefore the light bulbs are still there and protect the radio, and then I can start to do my transmitter and receiver test, and after that I can give a status report to the owner, and then he can decide what we want to do with the radio. Is he still interested to restore it, or yeah, just will he put it into the storage, or I don't know, whatever. But yeah, I hope you understand a little bit what you can really do with this light bulbs, and these light bulbs are really important to use it in your lab while you are taking old equipment back into service. And yeah, this is easy to build it by yourself, so this is really a nice homebrew project for a weekend or so. It is cheap and it is easy, and as you see, the schematic is really easy, so nothing special at all, and therefore that is what I wanted to show you. And yeah, if this all makes a little bit sense to you, yeah, please give me a big thumb up for the video, and well, catch you next time. Bye.